All right, I think we're getting a few more people cycling in, but they can just catch up as I'm starting in here. So this is the Corridor Trail, the virtual version of it, I guess. It kind of sucks not seeing you all in person, but I'm happy to at least do this virtually for everyone. I'm Andy Bosch, Regional CAD Coordinator with Kimley Horn. This is part one of the two-part series, so hopefully I get you hooked enough that you'll come back to see how the story ends here, with the second part coming later this month. But just a little bit about me. Like I said, I'm the Midwest Regional CAD Coordinator for Kimley Horn. I've been in the business for about 20 plus years now, and I've done a wide gamut of projects, everything from private development to big LRT projects here in the Twin Cities area. But right now, currently, I'm doing more roadway projects and also helping out users try to make the most out of Civil 3D and make sure that they understand practices and best practices. So this whole series that I'm giving here was something I did at AU in 2019, which feels like a couple lifetimes ago now, but this was taken I think a couple nights before I actually had to give this presentation. So hopefully we can all get back to that point where we can be face to face and enjoy some of that kind of stuff too. So when I started coming up with this class, my original thought, my thought bubble was kind of going towards that old game that I played in grade school that was even in color. I think it was just one shade of green that I was dealing with. And I think that's kind of everyone's thought bubble when I came up with this idea. But really what I'm thinking about is kind of that process, that long process to get from point A to point B and not knowing exactly how you're going to get there. And I think with corridors, it can get very complicated in a hurry, because what you're trying to do is take a 2D design and make it into like a 3D world. And it's very complicated, and there's some limitations, and there's ways that you have to kind of work around that system to get to that final ultimate goal, which is a good 3D model. And what I'm really looking for is using that 3D model to give me good earthwork numbers. So the 3D model can be used for other purposes, getting those good surfaces, but my ultimate goal is like I want to use it for my quantities, and I'm going to use it for my cross sections. So the purpose of this class is trying to step through for not only some of the beginning users, but maybe for some more advanced users as well, to try to understand some of the inner workings of Civil 3D or Corridor specifically inside Civil 3D. And I'll say that some of the stuff for you new users might be over your head a little bit, but just hold on tight with me. I'm just giving you a little glimpses into what it can do. And then you can kind of deep dive more into it because that piece is there. So just try to hold with me, and I'll get you through the whole thing here. So what we're going to go through this particular class is going to be subassembly review. We're going to go over some of the out-of-the-box stuff, and then how you can create some custom subassemblies, and not just using SubAssembly Composer. And now I'm not going to make this a SubAssembly Composer class. That could be its own class in its own, but I'm just going to touch on a few ideas, and also how you can make some custom subassemblies right inside Civil 3D for use in your corridors. Then we're going to get into Codeset Styles, manipulating Codeset Styles. So not only can you see your design better, but you can understand how to label things better inside your cross sections. And I'm going to give you a couple different options and how to lay that out and help you better see, as you're starting to put your sub-assemblies and your assemblies together, what you're actually producing. And then we're going to get into an example of intersection grading, and also trying to maybe understand how we could utilize corridors to grade out ped ramps. And then at the end, I'll wrap it up with Q&A, and we'll just have you type in your questions into the question bar, and then I'll try to go through those and answer those as well as I can. I will say, if there's anything here that you want more detail on, feel free to reach out on me. You can probably find me on LinkedIn. Feel free to connect with me on there, and then I can try to answer any other questions for you. So with that, I'm going to go live here with some demonstrations on this stuff. So wish me luck. Let me switch over to my right view here. And just to make sure that everyone's on the right baseline, I want to give a few like just general definitions of certain things that you're going to come across when you start working with corridors. Right now, what I have up on screen is really just an assembly here that I've got all the codes turned off. You know, this is my assembly here. This is a subassembly that I got all the codes turned off. And this is a 3D view of this defined assembly along an alignment here. And I just want to kind of help define what assemblies are really made up of. Assemblies are made up of points, links that connect those given points. And when you get 3 or more links, you can define a shape internal to those links. And those are all useful things that we can utilize in our design later to either make surfaces or grab quantities from, or even create labeling. And some ways that we can do that, if I zoom in on this a little bit, I'm going to go to the properties of this one. And right now, all these are set to, my point codes are set to hinge. So they're displaying, and I don't know if you can see that well enough, but they're displaying little nodes at each one of those points. If I go in here and start defining, say, the top link, let's see if I just put top on there, you can see that that now defines that top link, and that's based on the Codeset style. I'm going to go over that a little bit further down the line, but just to give you an idea there. I'm also going to define the datum, and you can see how that starts to build along our corridor. Now, along our corridor, every time this assembly gets placed, it's called a frequency. So you can see these frequencies starting to connect here. One of the other cool things is as we've got these hinge points, and we can also do certain things like call out elevations. We can start doing labels for each one of these points. And that gets helpful when you start getting into creating cross sections and doing labeling that given way. And I can also put in, I think if I do a link here, and if I see I put link in there, now you could see that we're starting to get feature lines build linearly along our corridor. And what's happening is similarly coded links, if they're defined proper in your Codeset style, will connect along your corridor. And this will make for better definitions and surfaces, as well as utilizing for extraction for targeting for other corridors. Again, I'm giving you some definitions here just to try to give you a baseline, and I'm going to touch on some of these points a little bit further down the road here too. So that's just kind of a baseline for assemblies and subassemblies. I'm going to switch over to a different view here. And we're going to go and look at where we start from. And I always push my engineers before I start trying to define a corridor to really think about what does our typical section look for this given roadway, because it's really hard to take a 2D design if you look at just line work and know for sure what you're supposed to be designing in a 3D world. You won't know what the cross slopes are. You don't know what the curb style is. You don't know the depths on any of the given pavement sections. And you might not know that right away, but it's good to start having this discussion so you can start building your assemblies the proper way at the beginning rather than trying to redo it more towards the end when it gets harder to introduce different assemblies into the equation. So at the top is what I have is my defined typical section that hopefully I've gotten by off with my engineer. And I'm just showing one half for the purposes of this class, just to help illustrate what's going on here. So what I have below here is how you could do this section with the out-of-the-box assemblies, subassemblies. And what you're going to notice is the big difference is that you're not really getting that good bottom definition of the corridor with the out-of-the-box assemblies. They're a little bit lacking in definition when it comes to that datum surface that we need. And the reason why I'm concerned about the datum surface is that I don't want to do hand calculations when it comes to earthwork. I'm putting the effort in to create a model. I might as well get as much out of this as possible. So when I look at this, what I'm really looking to get at the end is this given area here that's in blue. I want to figure out that fill area. And with this defined out of the box subassembly, you can start seeing where we're a little delinquent on what it could build. Like our curb definitions aren't giving me that layback slope. I'm not getting definition for topsoil placement. And then we start moving to the right and we start getting into daylight assembly. And thinking about some of the other limitations, especially when it comes to the daylight assembly, this is the out of the box generic daylight assembly. And I don't know if you've ever looked at this one, but even custom subassemblies I've created don't have this many input values to it. This is complicated. This isn't very straightforward. I'm not really sure what's happening with this one. It's a little too much. I would say that if you're going to use an out of the box daylight assembly, I would utilize either the min or max width option. A little bit more streamlined. And one thing to note with this, because again, I'm looking for that depth, you can place topsoil placement on all these. And there's this place line material option. When you click on that, you can do it to all links. And you can then define that down here. And normally what I do is just set these all to 4:1, same depth and same code set style. I'll get into what that code set style is going to get you a little bit later. So that's out of the box. Probably a little underwhelming for if you're going to get into some heavy roadway design. It's not going to get you to the full point of really what you want to see, not only just for your cross sections, but what you want to get out for earthwork. So I'm going to cycle down and show you some stuff. This is some more custom subassemblies. And this is what you can start to build in the SubAssembly Composer. Now, if you haven't heard of the SubAssembly Composer before, that's a tool that resides outside Civil 3D. It's a separate tool. Like I said, I could probably do a whole class on that. I think if I go here, if I pull it up, this is SubAssembly Composers. And I got 20, 18, and 15 on this given computer. Again, I'm not giving you a class on SubAssembly Composer. I just want you to make aware that there's a tool out there that you can start to utilize to make your own subassemblies. And it's a very powerful tool at that. I'll say that there's a few things that you should keep in mind when you start in. There's some great AU classes from Katie Mercer, and I forget the other gentleman's name that has given a couple classes that I've found very beneficial. But there's a couple other things to keep in mind when you start doing these, is that when you start getting into SubAssembly Composer and start thinking about codes and code set styles, and I hit on that a little bit, but one thing I wanted to point out is when you go to this location, everyone should have the same. It's on your program data 2020. And if we go to, let's see, this file right here, it's just a codes file. It's just a text document. This has all your predefined codes that are out of the box. And the reason why I bring this up is if you're starting in on SubAssembly Composer, it's nice to have consistent codes. And you'll see that as I walk through this more, that the more codes you have, the more picks and clicks you will have further down the road, whether you're creating surfaces or if you're doing labeling. And there's probably a few other items in there as well. But it's good to think ahead a little bit and understand that these codes are important. And if you have them more consistent, it's going to make your life easier. So a good place maybe to start would be looking what is coming out of the box. Really, this text file was meant to be able to edit these, and this would in turn edit the out of the box subassemblies. I've never tried it. I don't know if I would suggest trying to edit these. I just want to show you that this document lives here. One other thing to note with custom subassemblies, if you are going to go down that route, is if you do create one, they are kind of difficult to network through your whole office or through your whole firm. When they get created and you import them into your tool palette, they get placed locally on your machine. and you can click on imported tools, and this is all my custom subassemblies I've brought in. Now there's a couple tips and tricks that you can go through, and I've got a write-up from my AU class that you can ask for that will show you how to network these. Basically, you just got to copy these down and maybe use a batch file to push them back onto other users' computers so they have all this information. Autodesk didn't make this very user-friendly to distribute those custom subassemblies. So thinking about these custom subassemblies, one of the things that I did, I created this integral curb and sidewalk one where as these move in and out, my sub base will interact with my base behind the back of curb, and it'll even get rid of the topsoil placement in between. And this has been a very handy one. We also have one where your top of curb can adjust up and down. And I'm even thinking about making even a bigger one that has gutter pan adjustments where kind of like all these can be tagged to either alignment or feature lines to adjust those elevations, making a more robust 3D model for your corridor. One of the big ones that I've created was this one, and I'm more than willing to share this one because this has saved me a ton of time, is an assembly that I call Super Slope because of how much I hate the out-of-the-box one. Is one of the big hindrances out of the box one is if you're in a fill condition, it's always going to want to go into a negative slope. And that's difficult, and sometimes, especially if you're doing a recon project, say in like this instance up here, maybe you don't want to capture water down below. Maybe you want to have it look like this. It's difficult to get any of these daylight assemblies to do this out of the box. There is one generic assembly that you can do it with, but it's not very robust. So I created my own SubAssembly Composer, giving it a couple different parameters. So just giving you an idea what you can do, I've got max and typical slopes for fill and cut. And what that's allowing me to do is say my typical slope could be a positive grade for fill and then negative for max. So saying if it can't solve for one, it's going to switch over and do the other. And I can also, I've added in some different inputs of saying like the max daylight offset distance. So that will always, so if I wanted to take it to say like a right-of-way line from my insertion point, I can say like always be within, if you go outside that 20 feet, you're going to tag it right at that 20-foot mark. This has been a very handy one. So I'm kind of teasing you with some of the stuff that you can do with SubAssembly Composer. So short of getting into SubAssembly Composer, there are a few things that you have the ability to do inside Civil 3D if you want to create, if you want to add more definition to your assemblies. And one of the options is underneath the Home tab, you can go to Create Design, and you can go to Create Polyline, or sorry, where is it? Create Subassembly from Polyline. So if I select this, I've got this closed polyline here, and say that I want to make this look a little bit more like this assembly up here. This is a custom one that I made that's got the layback slope. This is my out of box. This is about as good as I can do to get that to look that way. Let me just select this one. I'm going to call this sub base. I'm going to go ahead and hit OK. And now it converts it into an assembly. Now this only resides in here, and this is also static. I can't adjust this like I can with other assemblies. It's just a way to add in a static assembly, subassembly to your overall assembly. So if I look, once I select this, I've got a few options of what I can do with this that are different than, say, the out-of-the-box options. When I select this, you'll see that I can add codes and remove codes. So one of the things I can do is I can modify the origin of this. Before it was over here, but I need an origin point of there. Now I can move it and I can attach it to this. Another thing I can do is I can start adding codes to this. So I could say datum, and I can add it to there. I can do the same thing again. I can go add code. I'll type in datum. And I know it's not showing up here, but promise me I'll show you in a little bit here. So now I got these defined as datum. That's going to help me define my surface. Let's say we want to get a shape in there. Again, we need 3 or more links to create a shape. That shape can be used further down the line to actually grab average end areas out of your corridor. So I'll click on shape and I'll start grabbing these links, and now I have a shape in here. It's not showing up, so let me switch over my Codeset style. I'm going to do assembly shape. No, that's not going to give me. I'm going to do assembly surfaces first. You can see that this is my datum surface. I get a Codeset style that just defines that. And I'm going to switch to one other one. I'm just going to go to standard. I think that's going to display. And now this is displaying that shape internal. I can select this again and say add code. And I can call this subbase. Again, knowing those out of the box codes, you're going to want to make sure that this matches exactly to those out of the box codes. Otherwise, when you get to the average end area, you might be grabbing sub base with a capital B or sub base with a lowercase b. You have to add those all in one by one. It gets to be a very monotonous task. So having more consistency is definitely going to help you in the long run. So I'm going to add in that code, grab here, and now that's part of that. When I want to add this, I'm going to grab it here, and then I'm going to say add to assembly. I'm going to move it over to here, and now it's part of this assembly here. When I switch the codes for this, if I want to go to, say, my, let's go assembly surface. This is showing me that datum surface now. Now I know I've got that good datum surface that I was looking for here, and I got my top surface. So you can see how you can start to expand your assemblies to get a little bit more robust than what you have with out of the box if you don't want to get into SubAssembly Composer. So enough on assemblies. Let's we're going to switch over to Codeset Styles. And I got to go to my model space. So I'm going to switch to, I'm going to make sure I'm at the right. Okay, we'll start here. So this is my standard Codeset style for how I label my cross sections. If I select this assembly, I look at the properties, it's my section style. Let's go assembly properties. Over on the wrong screen. Here's my Codeset style. And when we look at this, these are all the codes that are currently a part of any subassembly that's a part of this overall assembly. So what's doing is compiling these all in this location here, which you can't edit anything, because what it's doing is looking back to this Codeset style to understand how this given top link code should look. So my top link code right now is just displaying as general, and I'm not putting a label on. But my pave code, which is right on top of that same link, because you can dual up on your codes on any given link point or shape, I've got a % grade displaying. So if we look internal to that given code, this Codeset style, I've got all my links and I've got my points displayed. Right now, they're all being displayed as none because I don't really want those being displayed. If I wanted to label a given point in here, I would change the label style. So again, this is compiling all the codes within your assembly, and this is adding them to them. Now, if you want to add more codes into your Codeset style, important one is to click on here, and you can go click on any assembly and bring that in, or you can also go in and just add it. So when I look at here, if I look at this assembly, I can see that it's displaying the slope going on the back slope there. And the reason why it is because I've added a code in that's called slope, and I've also got the top defined. If I grab this assembly again, I can see right here, I'm missing some information. I got the top defined, but I don't have the slope. So I'm using one code to define the top surface and one code to actually help me label it. So all you have to do is put in a comma, add in one more. That code is then going to trigger what is defined in the Codeset style to figure out how to label. So this is a general one just for how cross sections look. Let's look at a different option here. If I switch this and I'm going to do assembly, let's do assembly shapes. This is kind of an important one too. And I talked about this before in the last one, is that I like to utilize assembly shapes to also pull out average end areas to give me quantities. And you can see I've got them defined for each given shape. If I look at this, if I go to assembly properties, if I look at codes, I've got one just defined as assembly shapes. So each one of these shapes has its own definition in it and giving it different coloring so I can easily see what's happening with it. So as I'm building my assemblies, if I want to make sure that before I get to the end and start running quantities, I could quickly switch these to assembly shape and see like, well, look, I'm missing my bottom of my ditch. I'm missing the information or a defined code there. If I switch this to sod, now that's displaying. Now I pick sod because that's the out of the box definition for the daylight options. So I just kind of stuck with that. That's why that's defined as sod and not say topsoil. One other one that I like to have in my back pocket when it comes to these assemblies. Oh yeah, this other one that I have too. Again, surfaces. Surfaces are very important. We utilize those for a lot of different things inside Civil 3D. And I maybe want to make sure before I start creating the surface that I got all my definitions set up right. And I've got different coloring defined for each the top surface and my datum surface. And this isn't so important anymore. In Minnesota, we used to have this thing called grading grade, which was a really complicated process. I used to have to define the difference between our base and our sub base. So you can see that you can add in some different ones just to help you see where your surfaces are going to be defined from. Again, if I look at this assembly here, this is my good old generic shape trapezoidal. It kind of comes with no codes in it, but I've got my bottom code is set to none. I really want to have that defined as datum. As soon as I do that, I'm getting that definition there. Now I've got confidence that when I run this, it's going to update right in the corridor and give me that good surface. If I select this assembly, I've got another one that I can give you. This is going to be codes. And this is kind of an important one because it helps you see how your assembly is being created, all the codes defined in different manners. So as I turn this on, like if you're trying to figure out like, I want to label this boulevard outside edge, what was that code exactly? You can switch it to here and see where that's being defined at, or how anything is getting defined. You'll notice here I pulled one code out and you can see how the sizing of this changed. I've changed this assembly to remove out the scaling like you do with other Civil 3D objects. It'll scale up and scale down. So if I go to settings, general, multi-purpose styles, and let me see if I go to the right spot here. Actually, I think it's label styles. And if I go to line, if I go to expressions, no, link, expressions. I added in, if I edit this expression, oops, let me move some stuff out of the way. I've basically added in this expression to keep these all at 0.05 height. That way they don't scale up and down and it's hard to see when you have these all on top of each other. Note that when you do have them on top of each other, if you hold the control key, you can find that grip and you can pull it off and then it's going to display. So this is your assembly as you're building it. Let's think about Codeset styles also affect how your corridor displays when you're working on it along your alignment and profile. And I think we're all kind of used to seeing this is you initially build it and all those similarly coded point codes connect to make feature lines along your corridor. And it gets to be not only the top ones, but everything below that. And it gets to be kind of a jumbled mess that's hard to look through to see what your design really is trying to do. So there's a couple different options that we have here. I've gone in and I'm going to switch this to just my plan feature line. Oh, actually, I'm going to go do this plan links first. So what I have here is I've turned off all the feature lines that are getting built that are below the finished ground surface, so I can better see how things line up. And you can see already this is my trail off to the edge, and I'm off by a little bit. So I got to adjust my assembly or I got to do some targeting. But how I did that was if I go into my corridor properties, and for some reason Autodesk thought it would be good to put a whole nother column for how the feature lines display separate from the Codeset styles of your points, links, and shapes. So they define in here. So if I go look at this in my Codeset style, if I click in here, and if I look at points, here's all my feature line styles. These will help define how the corridor itself will define those feature lines that go linearly along your corridor. So as I switched this, it turned off when it saw that given code that was below that was defined as, let's look in here as we'd had, say like edge of travel way, pave 1. I don't want to see that. I only want to see the top, like the center line or the back of curb. I'm defining all of those and turning everything else off. So once I flip that, it goes to this location here and rereads that. Now you can edit these. These are different than what the codes are over here. These you can't edit, but for some reason they decided to make it that you can edit these independent, good and bad, because sometimes it's difficult to get the corridor to read the Codeset style. One thing that we have kind of discovered is if you click this off, rebuild, it turns everything off, come back and click it on, and rebuilds everything. There's some nuances there. If you've got some extracted feature lines, that information might get dropped. It's kind of hokey, but also note that you can set this, and if you're seeing things aren't looking quite right, you can always kind of organize things in here and try to pick and click. You can select multiple and change their display in here. I've created another one where I took off. So again, each line that's perpendicular to the center line is a given frequency. It's placing that given assembly along your alignment and then connecting the dots in between those. Sometimes it's good to see that. Sometimes maybe I don't want to see that. Maybe I just want to see those given feature lines. And I showed this one a little briefly before. You can turn those all off, and it makes a lot easier to see what's happening on your corridor. Everything's kind of lining up. Again, I can see that I'm missing the target there. One other option that we have is we can actually infill in between commonly coded links to define a hatch pattern in between those to give you better definition of what's happening in your corridor if you're hitting all your targets again. If I go into the Codeset style for this, I'll go into the corridor properties. Again, when we go to codes, it's defined underneath the links. So I'm going to go in here and I'm going to go to link, and you can see that we've got this material fill area. Wherever I have pave, it's going to infill between those given links with this given hatch pattern. Same thing with my sidewalk, same thing with the sod in these given areas. So that's some different ways to manipulate Codeset styles to give you to really see your design before you get too far down the road and make sure that you're hitting all your targets and everything's making sense. We're going to switch over now, and now we're going to get into really the meat and potatoes, which is actually doing a little bit of corridor design. I got this intersection. I've got this roadway here teeing into this main main roadway. And just to dissect it a little bit more, this is my alignment here. I can select this alignment. If you don't know, there's this cool tool here. It's called Station Tracker. You can turn it on to all viewports. And now when I hover over this alignment, it's tracking along my alignment and telling me where I'm at in my profile and vice versa. I find this a really handy tool to let me know where I'm at. There's some other tools that are out there, but I find this really helpful. One thing you'll note too, and one thing I try to do quite often, depending on how I set up my alignments and profiles, if I do them in a separate drawing or if I do it all internal to the corridor, it just depends on how big things are, how much I want to split it up. But I've got this corridor here created and I got a surface created, but I'm sampling it on my profile down here. And I like visual cues. I'm not always great at remembering to go back and check to make sure I'm hitting every given point. So I can already tell, like right now, this point here is going to be really important when I go and build out this intersection. Am I hitting it right? And right now, if I go, I can make sure that I'm hitting that point there. Oh, I'm gonna hit right there, and now I know I'm matching up to that given point. I might have to come back later and fix that, but I just want to point that out. Another useful thing for getting your alignments and profiles lined up is projection of points. If I go point miscellaneous, I'm going to just do a manual one. I'm going to throw this right at this intersection here, or right at my end. Oh, it's not fine. Let me do it one more time here at my endpoint. There it goes. I won't give it a description. We can use that. I really don't care about elevation actually, because when I project my points, again, if you a profile view, projects objects to profile view, I can select this given point. I can select the profile. And when I get that, a lot of people just use the defaults, but just note that underneath here, you can project it to anything that's internal. That you can project it to a given surface or surface profile that's internal there. A lot of times what I might do is might just do my existing ground, because that's where I'm tying in at. I want to see exactly where that's at. Now, if I move this around, it doesn't matter what that elevation is. It's just always going to be hovering right on top of that existing ground line. So if I move that back to here, if I move it back to my endpoint, I'm right there. And now I know I'm tying in at the right location. So we got our profile set, we're tying in at the right location, but I've got these labels here that represent what my cross slope is. And we're going at 0.7 this way and 0.38 going up. We got like kind of a weird section going on here, but how when we've got our corridor defined as probably 2% cross slope the whole way, how do we get that definition, or how do we transition that area to be more accurate? Right now, this is what my cross slopes are. It's 2%, 2%, but we have to tie into this location here. There's a couple different options that you can do. You could utilize super elevation by setting the super elevation internal to the assembly itself. Right now I got right lane inside, and I can go into the alignment, and I could go in here and go into the super elevation editor and edit that way. I'm not going to get into that for this purposes, because what I really want to start showing is something that was introduced in 2018, which is offset alignments and profiles. So how we access this is I'm going to go to my offset alignment tool. I'm going to grab this. I'm going to select my alignment. And I got to drag this over again. So now I've got, and I got to see here. Let me do this again, because I got my distances down here. I'm going to grab my alignment. And so I'm going to do an offset alignment from start to end. I'm going to do one on the left, one on the right. You could do multiples, so then it would just keep stacking them up at 10-foot intervals going out from the center line. But I'm going to keep it at one, and I'm just going to do 11.5 and 23.1. So that's going to define alignment off our given center line at that given distance. So it'll just be parallel the whole way. This is the addition that was added in 2018 is that we have the ability to also create an offset profile. So this will be linked to the main profile, but just working with the offset distance and whatever defined slope that you have here. So what I can do is I can just leave this at -2%. And I'm going to link it. This is my FG, and you can only do defined finished ground surfaces. You can't do sampled surfaces. And I'm going to go ahead and hit OK on this. So now I've got two defined alignments running parallel to the center line, and I got profiles defined with those running along the same length based on the profile of my defined finished ground surface. If I pull this up a little bit, I'm going to create one of these profiles down here. And I'm going to go profile view, create profile view. I'm going to do holiday lane left. I'm going to go say create profile view. And I'm just going to plop this over here, pull this out of the way a little bit more. And when you look at the properties of this, so we still want to tie in, right now this is just at -2%, and I know that because if I go in the profile properties, there's this extra tab, and it's -2 the whole way, and it's starting from the south going to the north, so that's the first option there. I'm going to add in, I'm going to go and do it like this. So we're tying in, this is right at the start, this is right here, the station 0 plus 83.99, that's right here, but we really, instead of -2, I want to be -0.7. And I'm going to add in another transition grade, and I'm going to select this intersection right here, and I'm going to go -2. I hit enter. I don't have to add any more after this. It's just going to assume that's -2 all the way to the end. You could add more transitions in here by just clicking on it here and adding them in. If you pay attention down here, you should see just a slight adjustment made to that. So now I got that transition happening. I could go into here, I go into edit targets, I can select this, and I go my lane left. Actually, I want my elevation. I'm going to go in here, and I know it's my holiday lane left. I can add that profile in, hit OK, hit OK. And it's going to rebuild, and it's going to do that transition for me at that end. So now the nice part about this is anytime that center line changes, that transition on the outside is going to change because it's linked to this given profile. That's linked back to your mainline profile. So now you're kind of getting some interconnected alignments and profiles working off that one center line. A little bit more easy. So let's take this another, let's talk about how you can do transitions with offset alignments. I already have an offset alignment defined on my center line here. And if I look at it, like I'm missing this turn lane because I just had it defined. We can add in transitions to our offset alignments. If I select this alignment, I can go add widening. And you'll see, you always pay attention to your command line. I don't want to add it as a new portion. I'll just go ahead and hit no. I want to make one continuous one. And it wants me to get my start station. So that's where I'm full width. I'm just going to use my snaps, and I'm going to say my full width right here. And my end station where I'm full width, I'm just going to pick on the other side here. And my offset is 24.5. And now I get this transition happening. And you'll see that you'll get this box coming up, and this is kind of nice in some ways, is that you can now define some certain things. This is your entry and exit transitions, and you can transition in a couple different manners. You can do curve, line, curve, 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 reverse curve, curve, reverse curve. I'll say that these transitions work really well in nice, linear, no curves, just straight tangent lines. But when you get into putting a transition or a taper that happens within a curve, it depends on how you draw your tapers. Everyone seems to do it slightly different. This kind of struggles to do it the right way, and you might have to mess with some of these to get it to look right. For the most part, it works pretty well, but I will say that there might be 10% of the time that you might have to overwrite this with some different targets. So if I go linear, the other option I have is like I can do by length, and the nice part is I can do by taper. I mean, taper ratios are really what I want to have. So if I can go 1 to 15 because that's our standard. This is also a good way to double check my drafting of this given taper because the computer's doing it for me and I'm not relying on my brain to do it. I can see that things are lining up pretty well. And then when I go to the other side, I've got this taper happening too. This we can edit also on screen. You got these diamonds here that will maintain that taper length, or if you click on the circle, it switches it, and you can grab the beginning or end and just slide that over. So I'm just going to slide that over. I can go ahead and hit here. I'm going to go ahead and hit rebuild. And now I've got that definition there. Now if I go back to my center line, remember I had that sample, that surface, I can tell, oh, my surface is a little bit further out. Let me grip this, and I'm going to go to that endpoint there. And there you go. Now I can go, like, now this point here, which is a very important point, is going to line up for me. So we got some offset alignments here that are connected to the main line with some profile, and I got the same thing happening here. There's another nice tool that they introduced in 2018, which is connected alignments. And it's right below the offset alignment, so you can create a connected alignment. I can select this alignment, and I can select this alignment. As long as those two are alignments and have some sort of defined profile in it, I can create that connected alignment, and they have to cross. And it's going to ask me the location of my connected alignment. I want to have it in this intersection right here. You're going to get this little GIF that shows up saying, like, is this really what you want to do? You go ahead and hit enter. And then you got some definition that you can give it. I can enter in the radius. I'm going to 37.2. And then we're going to get this connection overlap. That's how far past on each tangent coming in and out do you want to see. 25 feels pretty good, so we're going to leave it at that. And you can see some different options here, the profiles that we're connecting to. Now these are my offset profiles that are connected to my offset alignments. It's utilizing those. I'm going to go ahead and hit OK. And now I've got that defined. I'm going to go ahead and build that profile out real quick here. I'm going to go profile view, create profile view. I'm going to grab that. I'm going to select it on screen because I don't remember exactly what I called it. Alignment, create profile view. I'm going to pop that in down over here. And I'll show you, you'll notice a few things on it. I can go ahead and go edit labels. I'm going to import a set here real quick just to label it. Okay, hit OK. And now we got some labels on there. So you can see that when I grab this, I only have the option to really edit this. If I go into my geometry editor, I can really only edit it between in the curve section. And if I can add a point there. I could make a really nice ped ramp that no one would approve. Or I could, if I try to go over here and do the same thing, it doesn't allow me. The only thing you can do is slide this along that tangent, which I wouldn't recommend because the whole idea is that you're trying to make that a connected profile. So let me just remove that. I'm going to take that out. So now we got a connected alignment. So now we can infill in this area here. We've got an alignment and profile that syncs up right this location. We've got an alignment and profile going along here. The other option that we could do, I mentioned this before, is you could go into feature line, create feature line from corridor. You could grab this corridor outside edge. You can grab it one more time to say, like, I want that edge of travel way. And you can create an extracted feature line that's will always update with the corridor. But I'm just going to use this alignment and profile. I just wanted to highlight that that's another way to make things interconnected. So now what I can do is utilize this alignment and use a couple different corridors, or I can add another baseline into this corridor here to define that curb return. I'm going to go in corridor properties. Yeah, thanks, Kimberly Horn. I'm going to add a baseline. I'm going to select that baseline there. I hit OK. I'm going to give it it's the only option I have. I'm going to add a region, and I'm going to use my lane left, curb right. And I'm going to define it from this endpoint to this endpoint. And then I'm going to do some targeting. I got my lane. I'm going to select alignments from my drawing. I'm going to select these two alignments. And add those in. And now I don't have to split this region into two different areas because I'm crossing over those corridors. It'll automatically do it for me because we've got this option here. It's going to just target to whatever's nearest to the offset, target to nearest offset. So whatever's closest to the baseline is going to be what the corridor is going to use. So I got my lane. We got to give it elevation yet too, so we got to add some profiles in. So I'm going to grab this alignment. I'm going to add that in. And then I got to add one more in. I got to select this alignment, and I'm going to add this define profile in. I'm going to hit OK. Again, the same thing in here. It's going to target to nearest offset. So no reason to split this region up into two different areas. I'm going to go ahead and hit OK. I'll rebuild the corridor. And now we've got that defined. But you can see my frequencies aren't seeing that point where they cross over. So we can edit that and go in. I just have to add another frequency. I'm going to click inside that region, and then I get this box. I can select this plus sign, and now I'm going to hit on this intersection, and now it's added down here. Once I hit OK, it gives that better definition. So now again, I'm making sure that at this point, everything's lining up. So now I have this curb return done and pretty well defined. But if we want to take this a step further, we can also start figuring out how to do the ped ramp. Now I rambled on a little bit too long, so I'm just going to talk about how to do an offset alignment from a connected alignment. So we already talked about doing an offset from a main line to get the outside edge here. We did a connected alignment, but I have an assembly here that I created that out of SubAssembly Composer that I can adjust the back of curb. So why not do that? Why not do that? And I can add more definition in here. So what I'm going to do is I'm going to do another offset alignment. I'm going to select this alignment, and I'm going to do from start to end. I don't want anything on the left side. I only want one on the right. I'm going to go 2.17. And now what gets interesting is that we have to go to the create offset profile. So normally we would think about curve. We could, we got to go down, back. I'm trying to get to that. What's that slope to get to the back of curb? To save myself time, I've created a handy dandy little spreadsheet so I can enter in some of the stuff. So if we got gutter width of 1.5, our gutter slope, and a curb height of this, and overall curb width of this, my full slope to get that full curb height is going to be 18.72. That's what I'm going to enter in here. I'm going to say 18.72. I'm going to hit OK. And I am going to go ahead and then create this profile view. So now I got a connected alignment, and then from that connected alignment, I've got an offset alignment. I'm going to go profile view. I'm going to create profile view. I'm going to grab that connected one, and I'm going to create that profile view. Plop this down here. So now what I can do is I can go into my profile properties again and start adding in my transitions for my ped ramp. I'm going to go into here. I'm going to go to this point right here because this is where it's going to be my full width still. I'm going to go 18.72 because it's got a transition down. I'm going to go here, and just to remove it, and I know that this from doing it enough times is -4. I'm going to go to here, -4, and then I'm going to come back up to endpoint and go 18.72. And so I've got that transition happening there. Full height, transitioning down in between these two stations, 0 height curb, and then transitioning back up. And if you look down here, once I hit OK, it'll put in that little divot into my curb. And I can go in here, and I'm going to go edit my targets. And you can see there's a custom one that I have. I'm teasing you to get you to start learning SubAssembly Composer. I can add this in and hit OK, and now that's going to rebuild. Now you can't see it here, so just to make sure you don't think I'm a liar, I'm going to hit Section Editor, and you can see that that curb height drops on the backside. Now, I was planning on getting into more details on this, and like I said, I'm up against time here, but I'll describe that I will go through sometimes the effort of modeling out these ped ramps kind of in this manner here. For this instance, when you go linearly, I'll define alignment at the front and the back. Again, I'm sampling these given surfaces so I know where I'm targeting to. I'm projecting points like I did down here, just to make sure that I know where things are at. And then I can start adding my profiles to this. These aren't as dynamic, that you've got to pay attention to what's happening. You're sampling this surface over here and this surface, making sure that they line up. And I usually add a lot of labels to things as well. I also say that you can do radial ones like this as well. It gets to be a little complicated. And I will note too, nothing is perfect inside AutoCAD. I think we all understand that. Every once in a great while, these offset profiles like to go static on me. And I have asked AutoCAD why, and they haven't given me a good reasoning, but just note that you can switch it back. It might go like this, and you'll go in and you'll see this when you select the profile, and that's bad. Go in Profile Properties, you should have the option to switch this back to dynamic. Once you do, everything should sync back up. So just note that. I can't pinpoint what causes it or why it causes it. It just happens. So just to give you a teaser, this was kind of what I was ultimately going to get at, was this is kind of the full build out of that. You could extract a feature line, or you've got that alignment on the backside that you could use as a target. Basically what I have is just another, if I go edit targets, I've just got another region right in here that I'm using the backside of the walk as my alignment profile. I can target the front edge of walk with an offset and elevation, and also use that back of curb as a target for offset and elevation. And there you got almost the whole curb ramp defined. Again, understanding whether or not your engineer wants you to go through that level of effort to detail that out, I would highly recommend doing that first before you go into this. Sometimes it's nice because you have a cross section that might land right on this curb ramp, and you want to define that a little better. So since I'm going over time a little bit, so I'll try to wrap up so we can get into some questions. So just to recap, we start off by looking at subassemblies and some options and limitations to those, what you can do inside the box, outside the box, how you can utilize some of the creating your own internal to Civil 3D, and starting to get you to think about utilizing the SubAssembly Composer to create better subassemblies. Codeset styles, different ideas for how you manipulate those codeset styles so you can see how your assembly is coming together. And not only that, how codeset styles can affect how your corridor looks and giving you a better option to see any potential issues that you might be missing when you have just all those feature lines on. Offset alignments and profiles, different ways to utilize those. They're handy tools. Definitely utilize them. They work really well. I find that it's easier to find offset alignment profiles because they're named rather than using a, say, polyline or a feature line that you're trying to see what's targeting. This has got a name. It's interconnected to your main alignment, so you're kind of working in tandem. It's everything's kind of interconnected, which is pretty nice. And then looking at intersecting grading and a little bit of the ped ramp design. So with that, hopefully if you've got some questions, feel free to input them into the question and answer bar. I know I went through a lot of stuff here. Hopefully this struck some interest in you and some different ideas on how to approach this. And there is a whole nother section of this to come where I get into one more grading option, thinking about how to do earthwork analysis and a couple different options. And yeah, and then wrapping up with that. So the only question I got is somebody wants me to do a class on SubAssembly Composer. So I will take heed of that. I've never tried to do a class on that. I would say I'm a novice at best. Let's see what else we got here. We got a couple other ones. One from Brian Lewandowski. Oh, he's answering. Yeah, it looks like I just blew everyone away with too much information like I always do. So hopefully this helped. I really want to try to give everyone as much information as possible, and sometimes I go a little overboard, but I believe you've got this. If I can do it, I think most all of you can get to this level. So let me see if there's any other questions. Have I run into issues between SubAssembly Composer 20.5.2 and 20.4 install? I have not. Honestly, I get into SubAssembly Composer, it feels like every 6 months or so, and I haven't messed around with the new version yet. So I don't know of any potential issue. All right, I think with that, I'm going to stop sharing and let you all get back to your day.